My name is Avery Metcalf. I'm going to be talking about the real-time transport protocols. The RTP is a way of structuring data packets so that they can be delivered across the internet at fast speeds and resembled into a smooth flowing stream suitable for delivering voice or multimedia in a natural way. Without such protocols, voice over IP would be impossible. I'm gonna be talking about some real-time applications that you can use with this. Um, so the client server RPC is an area in which the UDP is widely used. You can also see these in some real-time multimedia applications such as the internet radio, music on demand, video conferencing, internet telephony, video on demand, and many other multimedia applications. For example, in some applications in the 1800s, if you wanted to call someone, for example, like an operator, they would have to physically connect you to a different wiring route by rearranging a jack plug. Today's internet is divided into a series of packets and wrapped inside instructions that will help it perform the requisite switching. Each packet can squeeze through the internet traffic as the bandwidth permits it to. All right, so next we're gonna be talking about the two aspects of the real-time transport. Firstly, the first aspect is the RTP protocol for transporting audio and video in packets. And the second aspect is processing that takes place to play out the video and audio at the right time. So as you can see from the book, the figure on the right, this is the multimedia application in the RTP. It will consist of multiple audio, video, and text, and many other streams. And then these are fed into the RTP library, which is in the user space, along with the application. The library will then multiplex the streams and encodes them into TRP. On the operating system side, you can see that the UDP packets are generated to wrap the RTP packets and to the IP for transmission. Then that reverse process happens at the receiver. So in figure A, this one right here, shows the protocol stack. And then in figure B, you can see the packet nesting. All right, next we're gonna be talking about the functions. So basic function of the RTP is that it multiplexes several real-time data streams onto a single stream of UDP packets. And UDP streams can be sent to a single, which is called unicasting, or multiple, which is called multicasting destinations. And because the RTP uses normal UDP, its packets are not treated specifically by the routers unless normal IP quality of service features are enabled. In particular, there will be no special guarantees about delivery and packets if they're lost or delayed or corrupted or anything like that. The third bullet, the RTP format contains several features to help receivers work with multimedia information. Each packet sent in an RPT stream is given a number higher than this predecessor. This numbering will allow the destination to determine if any packets are missing. All right, next we're gonna be looking at a RTP header. So as you can see, an RTP header is 32 bits, and it can potentially have some extensions. First, you have the version field, which as you can see is 2 bits. Next, you have P, which indicates that the packet is padded to a multiple of 4 bits. The X extension indicates the extension is extension header is present. Next, you have the CC, which tells how many contributing sources are permitted. Next, you have M, which is an application-specific marker bit. It can be used to mark the start of a video frame or things like that. Next, you have a larger bit payload type. This field tells which encoding algorithms have been used. And after that, half of the bit is sequence numbers, which is a counter that is increased to on each RTP packet sent. It is used to detect the lost packets. Underneath that 32-bit, you have timestamps, which is produced by the stream's source. To note, when the first sample of the packet is made, this will keep the value, and the value can help reduce the timing variability called jitter at the receiver. Next, you have synchronization source identifier. This tells which stream the packet belongs to. It is the method used to multiplex and demiplex multiple data streams into a single stream of UDP packets. Then after that, you have a contributing source identifier. These are used when the mixers are present in the studio. In that case, the mixer is then the synchronizing source. So after this, you have the real-time transport control protocol. This is also known as the RTP little sister protocol. Just like the RTP, it will be defined here in the RFC 3350 and handles feedback, synchronization, and the user interface. The first function can be used to provide feedback on delay, variation in delay, or bandwidth, congestion, jitter, and other network properties to the source. This can be used to increase the quality when the network is functioning well, and to cut back the data rate when there's trouble in the network. For example, when the bandwidth increases or decreases, either one, during the transmission, the encoding may switch from MP3 to 8-bit PMC to delta encoding, whichever is required. There's some issues that happen with this. The RTCP reports are sent to all participants. So this can cause the bandwidth to grow large with a big group of multicast applications when there's large groups using this. To prevent this, the RTCP senders scale down the rate of their reports to collectively consume no more than 5% of the media bandwidth. The RTCP also handles inter-stream synchronization, and the RTCP also provides a way for naming various sources. So this is my presentation about the real-time transport protocol. Thank you.